The depth of water in meters left in a dam T hours after the sluice gate was opened to allow the flow of water to drain is given by the equation d of t is equal to 28 minus 1 over 9t squared minus 1 over 27t cubed. In 11.1, we have to calculate the average rate of change in the depth of water during the first 2 hours. And in 11.2, we have to determine the rate at which the level of water is decreasing after 16 hours. This question is from the grade 12 September 2018's preparatory exam. You can go ahead and pause the video and then try out this question, then play the video for the solution. To understand this question, you have to imagine there is a big dam, and this dam is filled with water. And then there's this special gate, which is called a sluice gate. Now, when this gate is opened, the water starts flowing out of the dam. And the depth of water in the dam is changing over time as the water flows out. Now, the equation d of t is the formula that helps you measure how deep the water is at different times. So here, t represents the number of hours that have passed since the sluice gate was opened, and then d of t tells us how deep the water is in the dam at that time. For example, if we wanted to find out how deep the water would be 1 hour after the gate was opened, then we would substitute 1 in place of t in the equation. Okay, now that we understand the scenario, let's break down the first question. So the first question is asking about the average rate of change in the depth of water during the first 2 hours. So we're really just trying to find out how much the water depth is changing on average every hour within the first 2 hours. So that will be from 0 hours before any water came out of the dam all the way to 2 hours. Now, whenever we want to find the rate of change, we're really speaking about the gradient, because gradient measures change. But in this first question, we're really just trying to find the change within this first 2 hours. So because we want to find the rate of change, we're going to use the gradient formula for this. So the gradient formula, as you would have seen already, is that m is equal to the change in y, which is y2 minus y1, over the change in x, which is x2 minus x1. So how do we find the change in the y values? Well, remember that we are measuring, the hours are being measured from 0 hours all the way to 2 hours. So the y values, in other words, the outputs, we would find that by substituting, first of all, 2 in place of t into this formula, because t is just for the time, and then d of t tells you the outcome based on that time, basically how deep the water is in the dam based on whatever time we are referring to, which is 2 hours in this case. So that's really how we're going to find y2. We're going to find y2 by saying d of 2. And then we're going to have to subtract this by d of the second one. Y1 is going to be d of 0, because this is going from 0 hours all the way to 2 hours. So d of 0. And then we're going to put this over. Now, what are the x values? Okay, so if d of 2 is the y value, the x value that belongs to that is 2 itself. Okay, so x2 minus x1, that would be the 2 hours minus the 0 hours. Okay, because that's what we substitute in place of t to find the output or the y value. Okay, so let's calculate d of 2. So we're going to say this is equal to, and this is 28 minus 1 over 9, and then in place of t, we'll say 2 all squared minus 1 over 27 in place of t, 2 all cubed. And then we have to subtract this by d of 0. Now, if you see d of 0, this is actually going to be very simple to find, because when we're saying d of 0, remember the x value or the t value is 0. Where is your x value ever equal to 0? This is at your y-intercept. So this is really the y-intercept of this function. And the y-intercept in every function is that value that does not have any variable next to it. So really the constant. So you can also go ahead and calculate it, but this will make your steps much longer. You could have also just seen that if you substituted d of 0 and you placed 0 in place of t, all of these would become 0 and you would just be left with 28. So that's how we know that d of 0 is actually just 28. So we're subtracting this by 28 because we know that's what d of 0 is. And then this is going to go over what is 2 minus 0. That is just going to be 2. Okay, so you can go ahead and sub all of this onto the calculator. Let's see what we get. And when I substitute this onto the calculator, I get as a fraction negative 10 over 27. But then as a decimal, this is going to be rounded off to 2 decimals. It is negative 0.37. Okay, so we got the answer, but what does this mean? So first of all, you'll see that it is negative. Remember, this is the gradient that we just found, or rather, it is the average rate of change in the depth of water. So the fact that it's negative really just means that the depth of water is decreasing, which makes sense because water is coming out of the dam. So the depth of the water is decreasing by how much? It is decreasing by 0.37, and this is in meters. The depth of water is in meters and the time is in hours. So it is decreasing by 0.37 meters per hour within the first 2 hours. So the depth of the water is decreasing at 0.37 meters per hour. Okay, now moving on to the second question. The second question asks us to determine the rate at which the level of water is decreasing after 16 hours. So this is another question that is asking about the rate of the level of water. But in this one, you see, it's asking that we should find out how this water is going to be decreasing after 16 hours. So this one was within the first 2 hours. But the second question is asking for after 16 hours. So you will notice that both questions are asking about the rate, which is really the gradient. But this first question is asking for the gradient within 2 variables. But this one is asking after 16 hours. So in this one, we are finding the gradient of this function at exactly 16 hours. So this question is really asking us to find the gradient at a specific point, or really at a specific time, which is 16 hours. So we're going to take the equation of d of t, and then we're going to find the gradient of this function. So that is really just the rate of change of this function. So we're really saying d prime of t is going to be equal to, and we have 28 falls away because it's a constant. Then we're taking negative 1 over 9 and multiplying by 2, and that gives us negative 2 over 9 t, and then subtract 1 from that, which gives you 1, which we don't have to write. Then we have negative 1 over 27 times 3, which gives us, it will simplify to negative 1 over 9, and then we have t, subtract 1 from that, and that will have 2. So this is what we have. This is the rate, okay, at which this is changing. But now we have to find the rate of change after 16 hours, or really how much the water level is changing after 16 hours. So here we're just going to substitute in place of t, we're going to substitute 16 to find out the change in the level of water after 16 hours. So that is d prime of 16, which is equal to negative 2 over 9 times 16 minus 1 over 9 times 16 squared. And then you can put this onto the calculator and let's see what we get. And when I put this onto the calculator, I find out that d prime of 16 is equal to negative 32. Now, let's go back to the question so that we can see how we need to interpret this. You see, in the question, they ask for the rate at which the level of water is decreasing, meaning they already know it's decreasing by now. So we just have to tell them at what rate is it decreasing. So remember, the fact that this is negative, we found the gradient, okay, of a function, but we found the gradient of a function at a point, not at 2 points like this one. And we found out that the gradient of this function is negative 32. So the fact that it's negative just really means it is decreasing. But how is it decreasing? It is decreasing at 32 meters per hour. So the level of water is decreasing at 32 meters per hour after 16 hours. So now you see the difference between these two questions. In the first question, we had to calculate the depth of the water on average within the first 2 hours. And then in the second question, we just have to find out how quickly the depth of the water is decreasing after 16 hours. So really, both of them have to do with gradients. But the first question is speaking about the gradient, the average gradient, meaning between 2 points. And the second question is asking about the gradient at a point.